5 minutes. And when a file's there, run a program against it, and then move that file somewhere else. We can erase all that code now. Less code, less bugs, and let the database do that. And here's how that would work. The first thing I'm going to do is create a credential inside the database. Creating a credential allows me to securely store my username and password for the operating system inside the database. So the database is going to take my username and password, encrypt it, and save it inside the database itself. When we're processing the files, we would like to use my credentials in the file system, my identity to process those files, not the Oracle account. The Oracle account runs with lots of privileges. I have far fewer privileges. So I'd rather use my identity when processing these files for security reasons. So this was step 1. Next, I'm going to create a directory that points to where these files will appear. This is so my application can access and process these files. Part of my application will have this table. So this table is specific to my application. I want it to load the file name, the timestamp of the file, and the contents of the file. So I created a table that can do that. I wanted a stored procedure to be run anytime the file arrived. My stored procedure will load the file into the database. The stored procedure receives one input. It's of this new data type, scheduler file watcher resolve. This is the message that's associated with the event of a new file arriving. And it has attributes such as the file timestamp, the time of the file, the directory, the file name, and other attributes. I can then create the record in my table, and then using dbms log, load from file, get that file from the file system into the database. All I need to do now is tell the database about my stored procedure. I'm going to use the scheduler to do that. The scheduler is the thing that can run in the database periodically, right? So it schedules jobs to run on a recurring basis. So I'm going to tell it about my stored procedure and the input to my stored procedure, that event message. And I create this new thing inside the scheduler, my file watcher. I'm telling the scheduler, watch this directory. Look for files that match this mask. Use these credentials when you're looking for the files. And then run this. Anytime the file is greater than 10 bytes, go ahead and run an event against this. Generate the event, run my stored procedure. I enable that job, and once that's done, as files arrive in that directory, they automatically get loaded into this database table. So again, this automates something that used to be very manual in the past. We used to write a lot of code to achieve this same effect. Now we just write a very small stored procedure, and we let the database take care of running that stored procedure for us. Number 7, deferred segment creation. In all releases of Oracle, when you issue a create table or a create index, storage would be allocated for that segment right away. So as soon as you create a table, at least one extent would be allocated. These extents might be small, but they exist. It is a fact that if you do something small over and over and over again, it gets big. Right? So if you have lots of really small extents, you have thousands of them, that's going to be a lot of storage allocated. Many third-party applications do create thousands of tables and then only use 100 of them. So they allocate a lot of storage, waste space, and they clutter up our data dictionary. You go into Enterprise Manager, and there's thousands of extents out there, only 100 of which are really being used. This new feature allows us to defer, put off the initial extent allocation until we put the first row into the database table. So this is what it would look like. We're going to start by disabling this feature. This feature can be turned on at the database level. It can be altered at the session level, or you could specify it on each individual create statement. So you have many different ways to use this. I'm going to turn it off for my session and create one table. When I create that one table, there's actually 5 extents allocated. One is for the table. Another one's for the primary key on the table. Another one's for the unique constraint that I have on that table. 2 more are for the lob, the large object I have in that table. So one table, 5 extents allocated already. If I turn on it and enable this feature, and I create another table that looks exactly like the first one, except I called it T2 instead of T1, and I look in user extents, there is no change. No new extents were added. Not until I actually use that table. When I do the insert and then look in user extents, the storage would have been allocated because I needed space for my table, my indexes, my large objects. So as long as that table would stay empty, no extents would be allocated. It will not be until I actually need the storage that we'll go out and get it. This will tend to make install scripts run faster because the create table statements don't actually have to do any work. You wait till you insert the first record in there to do that. And it will make those install scripts only allocate space that's truly needed for the application by putting off those extent allocations until later. Number 8 is the flash cache. The flash cache that I'm discussing is a feature of the Enterprise Edition database only on Enterprise Linux and the Solaris platforms. So on those 2 operating systems, this next capability comes with the database. It's not available on the other operating systems at this point. This flash cache feature allows us to take a solid-state disk drive and use it as an extension to our SGA, to use it as a way to have, in effect, a larger SGA, a bigger buffer cache, if you will. So you can go out and purchase a relatively inexpensive solid-state disk drive, plug it into your Enterprise Linux or Solaris architecture, tell the database exists, and the database will start using the solid-state disk drive as an extension to the database cache. If you look at the database,